welcome back. It's good to have you here. We're going to continue on with circle vocabulary. This is part 2. We already did part 1, so if you haven't watched it, go ahead and do that now. We left off talking about arc. I'm going to go ahead and zoom this in for you just a little bit here. Oops. Come back here. There we go. All right, so we were talking about arc, and here was all the information. You were filling out the rest of the semicircles, the rest of the minor arcs, and the rest of the major arcs. Remember, that is going to be part of your notebook check. Let's continue. The next item that we have is called the arc addition postulate. Hopefully this sounds familiar. Already this year we have studied the segment addition postulate, and we have studied the angle addition postulate, and now we have the arc addition postulate. What the arc addition postulate says is that the measure of an arc, so any old arc that we have, but this arc is formed by two adjacent arcs, two arcs that are right next to each other. They share an endpoint. This measure of that single arc that's formed by these two is found by adding the measures of those two arcs, which we call the sum of the measures of the two arcs. So let's draw a picture and write a really brief equation for it. So draw your best circle right here. I'm drawing in pen, it always makes me nervous. There we go, sort of lopsided lumpy circle. Let's get a center, we'll call the center W, because why not? Let's make this one X, this one Y, and this one over here Z. So to talk about the measure of this arc right here, we're going to say the measure of arc XY. That added to, we need the measure of this arc right here, the measure of arc YZ is going to be equal to the measurement of the entire arc from X to Z. Okay. When we do the walkthrough video, you'll see how to use this, and we'll put some numbers in there and do a little bit of algebra on it. But for now, that is the basic information. Now, we had mentioned the measure of an arc, and so the next question, logical question to ask yourself is, well, how do you find the measurement of an arc? I'm so glad that you asked. We do that with something called the arc length. The arc length is the distance between the endpoints of an arc. We can write this one of two ways. So if you'll please give us maybe 3-4 lines, and if you'll put some vertical bars, so you have 3 sections. We're going to draw a picture over here on this right one. There are 2 different ways. Oh my goodness, I cannot spell today. There's 2 different ways to write the arc length. The first way is to write it as a proportion. If we write it as a proportion, it's going to look like this. We're going to use this symbol, that is alpha. It's a lowercase Greek a letter. Alpha divided by 2 pi r, which if you recall from part 1, is the circumference of the circle. That worked out really well. So alpha divided by 2 pi r equals the central angle theta, which is the angle that's creating the arcs between the 2 endpoints, divided by 360. Let's draw the picture so that you can see what we're talking about here. So here's a circle with center, I don't know, C, and we're going to have some endpoint, some arc here. This is the arc, and we'll call its length alpha. Remember that alpha is a lowercase Greek letter a. Kind of looks like a fish. All right, this angle right here formed by connecting those endpoints of the arc to the vertex, this angle would be theta. And then this distance right here is a radius, so the radius of our circle. Okay, and so here is how we write the arc length as a proportion with this circle. We could also write it as an equation. When we write as an equation, we're doing little more than taking this proportion and solving it for alpha. And so the equation looks like this. Alpha equals theta divided by 360, all of that times 2 pi r. So basically, we just took this proportion, we multiplied everything by this denominator here on the left. I'm going to go ahead and write a little bit about this symbol over here. Alpha, this is the lowercase Greek a, and its name is alpha. All right, to set you up for Algebra 2, Pre-Calculus, and onward, I want to introduce a brand new word. We're not going to do a whole lot with it, but I want you to at least be familiar with it so that it's not completely new to you, and that is the radian. Remember when we were doing trig and I asked you in your calculator, please make sure it's in degree mode, and some of you had to change it off of this thing called radian mode. This is what the calculator was thinking in. Radian is a unit used to measure angles, and this unit is based solely on the arc length and the radius. Okay? And it is found thusly. You take theta, the measure of the angle, and the arc length in relationship to the radius of the circle. So alpha divided by r, which means that 1 radian is the relationship between the arc length to the radius. We'll do a little bit of radian work in this class, but we'll leave most of that to your Algebra 2 and so on. Okay. All right, let's add some new words to our vocabulary, a little bit different from arc length and radian and what we've done before. And this is used to describe how we draw things inside of a circle. When we draw things inside of a circle, we can call things inscribed, or we can say the circle has been circumscribed. Here's what each of those words mean. Inscribed is talking about a polygon where all the vertices are on the circle. I'll draw a picture of what this looks like. They look the same, both of these. So I'll draw them in a moment. Circumscribed happens when a circle contains all of the vertices of a polygon. And it's going to look something like this. So we have our circle, center C, and then we have some points. Like that. So L, I, O, N. Okay? And we can say that quadrilateral LION is inscribed in circle C. So that's the first sentence that we can write. The next sentence that we can write is to say that circle C is circumscribed about quadrilateral LION. Please take a moment to note the different usage of these words. Inscribed is used to describe how the polygon is in relation to the circle, while circumscribed is used to talk about the relationship between the circle and the polygon. So we're talking about them in a slightly different order. Related to this notion of polygons being inscribed, we can also talk about angles being inscribed. So our next definition is going to be the inscribed angle. And the inscribed angle is an angle where the vertex is contained on the circle. And the sides of this angle are going to contain some chords of the circle. Okay, here's what it's going to look like. I'm going to draw a circle, the center L, and then we have some sort of angle that looks like that, and we'll name all of these points here. There they are. And so in this example, we can say that angle FHS is an inscribed angle of a circle L. All right. Nothing too challenging there. I'm out of room on this page, so I'm going to go to the next one. If you still have room on your page, you may continue. The next definition looks like it's going to take maybe about 4-5 lines or so. So if you have at least that much space, you should be good to go for the next word. If you don't have that much space but want to risk it, you're more than welcome to. Just be sure that you're going to write a little smaller. So the next vocabulary word is tangent. Now, we've already talked about this word before. This word showed up when we were talking about trigonometry. And I said, it has something to do a little bit with circles, but we'll talk about it later, guys, later. Well, later is now. So here we go. Tangent is a line that lies in the same plane as some sort of curve. And this line is going to intersect that curve in just one place. Alright, so this is a line that's in the same plane as some sort of curve, and it's going to intersect that curve in just one spot. So let's see here. We've got some sort of squiggly line going on like this, and let's say we want a tangent line to this thing right here. So it's going to touch the curve right there at just this one point. Kind of a weird example, because if you extended this, it would go all the way through, and that looks kind of weird, and I get it. Right now, you'll see this when you hit calculus, okay? For now, in this class, we're going to look at it in terms of a circle. The circle is our curve. It's a complete, beautiful curve because it doesn't stop. And the tangent line would be a line that sits something like that, touching in just one point. So if I labeled this, let's label this G, and let's label this one S, then we can say, let's label the line, shall we? Let's label it M. So we can say that line M is tangent to circle G at S. Now this point right here where the tangent line is touching the circle has a special name, and this name is the point of tangency. The point of tangency is that point of intersection between a curve and its particular tangent line. Okay. So for your notebook check, please, this is the next little section to make sure that you're following along with me here. I'd like you to please draw this figure. There's your figure. And I'd like you please to list out the point of tangency. And I'd like you to list all of the names for the tangent. Now please know that rays are allowed, so I'll give you one of them. If you look here at L and you go toward D, that is creating a ray. So one of your responses needs to be ray LD. There are plenty more tangents in there. There's at least one more ray, and there's a line and a segment. Please give me all the different names for that for your next check for your notebook. We only have one more word left to go, and we are done with this section. This word is the secant. You'll run into this word when you continue your study of trigonometry, so it's one of your trigonometric ratios. It also comes up a little bit in pre-calculus. A secant line is a secant that intersects a curve in exactly 2 points. So let's draw the picture of that secant. So here's a circle. Let's call it R. I'm going to put a line here. And we'll put those intersections as M and A. And then here's another line, and it will be O and N. And then we can say that lines MA and ON are secants of circle R. Coming up Thursday in class, we will do the walkthrough where we look at all the different ways that we can use this information to calculate things in a circle. Thanks for watching.